Section 3 of Chapter 7. We're looking at graphing a reciprocal function by using a table. So basically we just want to choose x's, and we can do this all day. All right, you just plug an x in, you plug it in here. It kind of stinks because there's a fraction, but that's fine. So we can just start making tables. You could also first start with what x cannot be. So we use like example 1 where we set our denominator equal to 0, and we solve that so we get 5 halves. So we know we cannot use 5 halves, right? So 2.5 cannot be used. So we could kind of center around that. That is our vertical asymptote. So if I draw this out, right, then I know I can't plug in 2.5, right? So I want to plug in maybe things around that, right? So one thing that you want to maybe think of when you plug in an x's is I have a 1 on top, and so I'm dividing by 1 of whatever my answer is here of my x, right? So I want easy numbers, right? So I want like a 1 down there. So I could just set this equation equal to 1 and solve it. And divide by 2, and we get 3, right? So 3 is probably a good x to pick, because when I plug it in, I know I'm going to get 1, and 1 over 1 is 1, and then 1 plus 2 is 3. So I know I get this 0.33. What's another good x to pick? Right, if I want 1, maybe easier numbers like a half, right? That might be good. So 2 in there. So if I, set the denominator equal to 2, then I'm only going to get a half on bottom, and a half plus 2 is just 2.5, right? So I add 5, I add 5, I get 7. So it's a decimal or a fraction, but that's okay. So 7 halves, so that's like 3.5. So I want to choose like 3.5. I choose 3.5. I know I'm just going to get a half plus 2, which is just 2.5, right? So I know I can go over 3. 1, 2, 3. And I'm going to get 1, 2, 3. And then I know if I go over 3.5, so a little bit in between here, right? 3.5, I'm going to get 2.5. 1, 2, 2.5. So just a little bit smaller, right? Okay. And then I can keep on getting smaller and smaller. As you can see, if I get 2, I get a 3, I get a 4, I get a 5. Isn't that just going to be smaller and smaller? Right, smaller and smaller, but not quite to 2, right? Because this is never going to go to 0. So I'm just going to keep on going lower and lower and lower and lower and lower and lower and lower. But what am I not going to cross? I'm not going to cross 2, right? So fix that a little bit. So really, I have this horizontal asymptote through here, where I'm not going to get cross that 2, because I'm always adding 2, and anytime I have a fraction, I'm not going to get closer and closer to 0. Okay, so then what's it doing to the left? Isn't it just going up and up and up? But I know I have this boundary where I can't have 2.5, so I have this vertical asymptote at 2.5. Okay, then what other fractions are good? How about 1 over a negative 1? Well, what would make a negative 1? So if this was negative, wouldn't that be 4? And then 4 divided by 2, wouldn't that be 2? So I want to choose 2. And I know I'm going to get out 1 over negative 1, which is a negative 1 plus 2, which is just 1, right? So I get this 0.21. So 2, 1. Then I can plug in 0 if I wanted to, but then I'm just going to get negative 1/5. But maybe you don't want to graph that. So what about a 2, a negative a half? Because a negative a half plus 2, isn't that just 1.5? So how can I get negative 2? Well, if I add that, don't I get 3? That would be 3 halves, right? So wouldn't that be 1.5? I know I'm going to get 1.5. So over at 1.5, I'm going to get 1.5. But am I ever going to get to 2? Right? Because anytime this is negative, aren't I just going to be subtracting as this gets bigger? 3, 4, 5. Isn't that just going to get a little bit smaller than 2? So I'm going to approach it this way. And then what is it doing to the right? It's just not going to cross that vertical asymptote. So there's my graph. Both branches. These are called branches. And we have a vertical asymptote, which is what makes the denominator 0. And then whatever we're adding to at the end after our fraction, that is going to be our horizontal asymptote. So we have a horizontal asymptote, and we have a vertical asymptote. But you can always just make a table, just plug in more and more x's, but you want to be balanced around what you can't plug in. So set the denominator equals 0 and then balance it by plugging in numbers.